with Phil Zito, episode 370. Hey folks, Phil Zito here, and welcome to episode 370 of the Smart Buildings Academy podcast. In this episode, we are going to be talking about energy audits for building automation professionals. As always, everything will be available at podcast.smartbuildingsacademy.com/370. Once again, that is podcast.smartbuildingsacademy.com/370. So we are living in a world right now where energy costs are increasing left and right, and we're seeing a lot of municipalities across the globe actually instituting energy reduction goals, carbon reduction goals, penalties for not hitting goals, etc. Which brings us to the topic of energy reduction. But how do you reduce something that you don't understand or have zero visibility to, which is the case for a lot of building owners right now? And if we're going to help our customers around the area of energy reduction, carbon goals, negotiating proper rates for their future purchase of utilities, then we really need to understand what is going on in their buildings, and they need to understand what is going on in their buildings. But how can you do this? Up until recently, it's usually been tied directly to some sort of energy savings contract. But now we are seeing a really prime environment for retrofits, and we're seeing changes to the tax code, or at least parts of the tax code with the Inflation Reduction Act, that are going to give us up to $5 a square foot based on up to a 50% reduction of baseline per ASHRAE 90.1. So we'll have someone who knows a lot more about that to talk about that on a future podcast episode. But before we get to that point, we need to really talk about how can we perform energy audits. And before we talk about energy audits, we want to talk about the two kinds, because most of you are not going to be doing a detailed audit. That wouldn't be beneficial. That wouldn't likely give you an ROI on your effort, because we want to keep our cost of sales low if we're not necessarily going to get a bite on the retrofit projects we want to implement. And for the owners watching, you've got a facility to run, so you want to get these kind of energy audits done in an efficient way. Now, there are tons of standards out there about energy audits that ASHRAE has, DOE has. There's a bunch of stuff around that. There's websites where you can actually perform an audit and immediately submit it to your municipality. I think one of them is buildingsync.com, or it's buildingsync.doe.com. What we're going to focus in on here is just a general audit. So I'm going to call it a simple audit. And we're going to go through a couple areas. We're going to talk about getting general information from the building. We're going to talk about understanding our building envelope. We're going to talk about schedules, load calculations, equipment determinations. All of this is giving us a site picture of what's going on. And we're going to overlay that with the past episodes we've done on understanding what sequences are running in the facilities, things like that. So without further ado, let's dive into the process. I do want to remind you that anything we reference here will be linked at podcast.smartbuildingsacademy.com/370. And if you find this information valuable, please give us a 5-star review on iTunes, like and subscribe on YouTube, or share this on LinkedIn, wherever you're listening to this. All right, so the first things first, we've got to figure out what we actually have in our building. And this is where we do the basics of the basics. We want to understand our building. We want to understand kind of how is it laid out? How many stories does it have? Where is it facing? Is it facing north? Is it facing south? Like, what is it exposed to? What is its square footage? And we want to get square footage that is conditioned and square footage that is not conditioned. We want to understand the two because oftentimes, especially in high rises, you'll have areas that aren't conditioned. And we want to know that because we want to take that into account when we're calculating energy density. We want to understand the age of the building. We want to understand if it is a leased building, if it's a owner-owned building. And the reason I want you to focus in on that is you really need to know that in order to make a sale. If you are selling to someone who's owning a property that they're just going to flip in a couple years, or they just want to churn tenants through it, that's going to be very different than, if it's a single tenant or it's owner occupied. That will have a big effect. And also, we want to understand the vertical market. Is this healthcare, K through 12, commercial real estate, all that stuff? And once we figure that out, then we get into really understanding the building itself. So what we want to do is we want to start to capture utility data for the building. Now, this is pretty easy to capture in a lot of cases, depending on the type of tenant. Now, if you have tenants and you have an operator and each tenant has their own bill, and then you have this kind of omnibus bill, this could get a little confusing. So we're going to focus on a simple example, and then we're going to move to more complex. So a simple example would be an owner-operated facility that does not have different departments that are sub-metered or sub-billed. It's just a single flat bill. And in that case, we want to understand, when was this bill issued? We want to get kind of the past 12 months. We want to understand who the utility is, what their account is. We want to understand their rate schedule, and we want to understand their billing dates. We want to understand what was their demand, what was their use, and what were their costs. So we just want to get a good picture. Now, what that's going to do for us is a couple things. It's going to help us calculate energy density. It's going to help us determine, maybe we want to do a soft start strategy. Maybe their demand is high because they're starting everything at the same time. It's also going to help us understand potential areas that we could go and tie in with utilities for maybe rebates based on density, things like that, and understanding who their utility is. We want to pretty much do the same thing for gas, right? We want to understand what is their gas, what is their consumption, and what is their cost there. So we want to figure out those things as well. What we'll do is we'll take all that information, gas, electricity, maybe they are a university or they're a muni and they're purchasing steam, purchasing some sort of hydronics. We want to understand that. Basically, any type of utility that they're consuming that we can affect. So this is where a lot of folks get kind of caught in the mix. If you can't affect the central utility plant because they're purchasing from the central utility plant from another central utility plant, and you can't affect its efficiency, you can acknowledge that because that's going to really help you understand energy density, but there's probably nothing you can do about that. So, I mean, you can increase the efficiency of the HVAC, but that's about it. All right, let's keep moving along here. We're going to want to understand how they operate and maintain their facilities. And now we want to just kind of start to profile out the building. We want to figure out, how's the building laid out? I'm just going to check my audio real quick, make sure everything's coming through good. All right, cool. We want to see how the building's laid out. We want to understand where the mechanical systems are and where they serve. And from here, we want to go and start building out. And this is where stuff tends to differ from a pure energy audit versus a building automation audit, energy audit, which is what you all should be focusing on. A pure energy audit would focus on things like glazing, insulation. They'd focus on building envelope. You would try to figure out, what can I do to the building envelope? Since I said this is a simple audit, we're going to be primarily focused on what can we control? What is what we control? Mechanical systems, scheduling, starting, sequencing, etc. So we're going to be gathering that kind of information. Once we get to that point, we want to start building out our occupancy schedules. Once again, going with the simple example of an owner, tenant, single tenant, it's going to be pretty straightforward. We're going to want to detail what are their schedules, And what are their schedules by spaces, if they have any? Because that's low hanging fruit. If they run the whole building 24/7, which not a lot of people do anymore, we're going to want to go and grab that. So, Christopher, I see your comment. I'll get to that in just a second, and I'll give you my thoughts on that as well. Once we have schedules, right? We have our occupancy schedules for HVAC. We can do lighting schedules as well if we have some form of lighting integration, or they have a lighting system that would be viable to integrate with. But that is another subject that I'll bring in an expert on lighting retrofits. So we'll just leave it at that, because I still think there's plenty of lighting opportunities out there, but it's not something our traditional audience addresses outside of the ESCOs, energy savings contracting organizations. All right. We can dive into things like plug loads. I don't necessarily recommend that because plug load monitoring is still in its infancy. And I'm still looking for stronger ROI cases. If any of you have done wide scale plug load monitoring and have seen positive ROI and have a case study around that, I'd love to hear from you. Love to have you on the podcast. Ever since my time with a previous OEM running an integration program and working with vendors that were in plug load, we could never seem to get it to take off on any of the projects. It just never seemed to happen. And then if you have any temperature schedules, any things like that, and if you have any area or time periods of peak occupancy, definitely want to look at that. So if you all are wondering where I'm coming up with all this, it's a combination of some stuff I grabbed off DOE, the Rocky Mountain Institute, as well as just some general EDUs where I typed in, just so you know how I do this. And I've covered this before in previous podcasts. I will type in like commercial energy audit file type XLS or commercial energy audit file type PDF in my Google search. And then I'll also do things like commercial energy audit site.edu or site.gov. By doing those, you get some pretty open source, commercially available documents that you can then take and utilize. You should not be inventing this stuff, folks. There's so many resources out there. This is like stupid simple. Really, if you go and you properly qualify the customer and you understand that they have a budget, they have an intent to buy, they have some form of organizational need to reduce consumption or reduce demand, if you can understand that, then going and running through one of these audits over a period of 3 to 4 hours to potentially build some quick hit retrofit opportunities is pretty simple. And it's a low cost of sales opportunity. So I highly recommend you do that. As well as when the capital market continues to slow down, the retrofit market will pick up. I've seen that. I've been through 3 recessions now. So I've seen that happen each time. Capital slows down, retrofit picks up. So I would be shocked if that didn't happen again. Let's continue along. So now we're going to look at what do we have from an HVAC perspective. And an HVAC perspective is super duper simple. We like to start with our hydronics and our large built up air handlers. And this is where Christopher mentioned that BAS energy audits should focus on trend data to drive decision making. So this is where we can start to pull that trend data once we identify the systems, if they have that. If they don't have trend data, this is things where like hobo sensors can come into play, where you can plug those in and just put them in and monitor the data. And the sensors are so much cheaper than they were when I first started in this industry. This is stuff you should personally have in your kit. All right, let's keep moving along here. So we're going to go and we're going to look for our hydronic systems first. Hydronic systems are going to be domestic hot water. It's going to be heating hot water and chilled water. So we want to focus in on those, and we want to focus in on our process loads and our primary loads. So our process loads are going to be things like our MDFs and IDFs. These are typically going to run 24/7. They're going to be partial load scenarios. And these are prime opportunities for saving energy, because I've seen a lot of people who have partial loads, but they run those partial loads off of a primary load system that is inefficient. And so this is a case where if you have enough process loads and enough load there to justify, you could potentially put in a smaller cooling system in order to meet that and potentially offset some demand costs as well as consumption costs. But we really want to focus in on the state of the equipment. What is the conditional state of the equipment? And you could usually, if you have any experience in the industry, you can walk in, listen, here's stuff running inefficient, here's stuff grinding. You could check the maintenance logs, etc. But we also want to look at set points, and we want to look at how these set points are controlled. So we want to grab the type of the system. We want to get the serial number. We want to get its capacity, its efficiency, its flow rate, etc. And we want to understand the sequencing of that system. So this is where we're going to start to pull all that in. And we do that for everything, right? For our commercial or our heating hot water and our domestic, and for our cooling. Then we move to the air side, and we're going to start to get our air side systems. We're going to start to grab primarily our large air handlers. We're going to grab our makeup air units, DOAS, 100% outdoor air units. And here we're going to be focusing in on condition and operation as well as sequencing and logging data. This is where, as Christopher mentioned, that trend data can come in handy. One thing I really like to do is look at a regression analysis of trend data, because trend data does not necessarily tell you the whole picture. And there's a lot of websites you can go to. If you just like type in Google and we type in regression of environmental or regression of temperature, and you do that, you can go regression of temperature, and you can pull in, all sorts of calculations that will help you do these regressions. Now, what is regression? So what regression is, and this is an important concept if you're going to do anything energy-wise, you may see, to Christopher's point, you may go and grab that trend and see that the air handler is running 100%. It's like across this entire period, 100%. But if you don't look at outdoor ambient, or you don't look at capacity, then you could be addressing an issue that's not an issue. So you have these regression variables that have BTU effects. So outside air has a BTU effect. The load of people has a BTU effect. So if you're a auditorium and you're running a 5-day conference, then your load for those 5 days, if that's your driving factor in your calculations, then you're going to say, oh my gosh, this is a huge load. Maybe this is inefficient, whatever. But you're not taking into account that you got 5,000 people and all of the heat they're off-putting. Or if it's design days for 2 weeks in a row. I remember when I lived in Dallas and we had, I think it was 90 days of 100+ degrees. If you don't take that into account, you are going to have a misrepresentation of the efficiency or inefficiency of the systems. So keep that in mind as you're logging this. Now, another thing where people get caught up, and it's a simple area to get caught up. They do an analysis and they grab the trend data, but maybe there's not outside air, or maybe there's not humidity data. Just go to the nearest weather station on Google. Just Google the nearest weather station. You can actually go, and I like to do weatherunderground.com, go to their map, click on the filter that says weather stations, and it'll list all the public weather stations. And so you find the one that's located closest to the facility and pull that weather station data. And you can often get the temperature and you can get the humidity for those areas. And that's going to be important because, as we discussed in the previous podcast, we're not just concerned about dry bulb temperature, we're also concerned about enthalpy, right? We want to be concerned about that moisture energy that we have to remove. So if you're in Houston, where I grew up, that's a huge factor. That's a massive amount of BTUs in the airstream that have to be conditioned out in order for the space to be comfortable. So you want to take that into account as you're logging this. But in a nutshell, this is really all you have to do is go to Google, grab one of these sheets. I will link to a couple and just go through, gather the data. And then once you gather the data, in a future episode, we'll be talking about what do you do with the data? How do you build a profile? How do you do that? I'm going to give you kind of a hint here because I don't want to spend too much time on this because this is a whole podcast in itself. But you can go to a variety of government websites, enter in the square footage and energy density and the area code and the building type, and you can get a energy efficiency rating compared to other buildings of that same vertical. And you get like a red, yellow, green, right? It'll tell you, are you good? Are you in the middle? Or are you bad? And if you're bad, then your job as a building automation professional is to determine what is having the effect that's making it bad. If it's glazing, if it's insulation, if it's envelope, those are things that we're not typically going to fix as building automation professionals. But if it's building pressurization, overpressurized or underpressurized, if it's operational inefficiencies like maintenance, if it's sequencing issues, if it's sensor accuracy issues, those are things that we can easily fix. And most utilities will actually give you an incentive to go and fix these. So you can bring money to the table or tax reduction to the table to your customers as you go and you approach these. All right, so that's how we're going to go and do a simple audit for a single tenant customer. Now let's shift gears to the more complex situations, which we're going to run into in a lot of the metropolitan areas where these energy standards are really being pushed hard. New York City, pretty much all of California, a lot of the West Coast, and we're seeing it trickle down the East Coast as well. So these are primarily going to be non-owner operated multi-tenant facilities. So how do we address this? Well, first off, you usually want to get with the property manager, right? The property manager is hopefully going to have a voice to who owns that asset. And so you got to figure out, is this part of a collection of assets? So is it a collection of buildings run by a property management firm for an investor? Like, what is the structure here? So you know who you're influencing. Because in my experience, unless there is a government mandate or this is a organization that has organizational mandates, it's all about how much profit can we get per square foot. That's just the reality. So that's your first thing to rule out, right? Is there some form of motivating factor before you engage in this and you sink your sales effort into this? Once you've determined that, yes, there is something here that is going to motivate whoever is the owner or manager to make a decision to be more efficient, then you go to that person and the fun begins. Because first thing you got to figure out is who owns the assets in the building. So there's a lot of different structures, but there's two primary structures. You're going to have owner operated assets, owner operated and managed and maintained assets. And then you're going to have assets that fall under the tenant that they maintain. So some tenants may maintain their own air conditioning, may maintain their own spaces, may have their own BAS, et cetera. Some may have all of that fall under the building owner, and then they simply pay utilities. So you have to figure out who owns the physical assets and who maintains them. Once you've figured out that, you also have to figure out the utilities. So is this utility pass through? Does each tenant have their own meter and their own billing? What is that structure? Because if the tenant has their own metering and their own billing, then going and trying to sell energy savings to that facility owner probably not going to be successful. You got to focus on that tenant and you got to figure out, does that tenant actually care? And in my experience, this is just my experience, the harder sells are the ones where the tenant owns the utilities, because it's usually a smaller ROI versus an entire building, depending on the size of the building. Your mileage will vary and it depends. I've got to research for a lot of these munis because I don't know off the top of my head if the penalties fall on the building owner, even if the tenants are paying their bills, or if it falls on the bill payer. I don't know that. And that'll be something very interesting to know. So right now we're at about 25 minutes. I want to give a couple minutes here to answer any questions any of you all may have around this. I do definitely encourage you to research this. It is a pretty low hanging fruit. That is, if you have a basic understanding of how to read a utility bill, is not terribly difficult to do. If you understand how to read an equipment plate, which quite honestly, if you're selling retrofits and you don't know how to read an equipment plate or do a site audit or do a site walk, then you probably shouldn't be selling retrofits. So we've covered site audits in a previous episode, so you could definitely go and refer back to that. But I'm going to pause, see if we have any questions coming in on any of the different areas. Hopefully this has been helpful for you and kind of demystified it. I know that when I first, so before I do any of these episodes, I do a lot of research, and I know this is one coming into it that I thought, oh my gosh, this is going to be hours and hours of research. It's going to be freaking crazy. And it was actually like 15 minutes. It was so easy. You know, as soon as I typed in commercial energy audit, file type, PDF, site.gov, I got all these PowerPoints in PDF format that literally walked through exactly what to do. And then it's just a matter of digesting that and saying, okay, I'm not an ESCO firm. I'm not a utility. What would I do as a BAS contractor? And then you just put it in that light and it becomes really simple. So I'll see what else we have coming in here. I got Christopher's question answered on LinkedIn. Not seeing anything coming from YouTube. So we're looking pretty good on everything. All right. Here, like I said, is what we can expect for the rest of the week. One of the big things with any energy audits is going to be, you know, your IPMVP measurement and verification to prove that your retrofits make sense. So you're going to have option A, B, and C. I'm not going to talk about option D, that's whole building modeling. But option A, single variable, option B, multivariable, and option C, which is just your baseline. We're going to go and talk about those in a future episode. But in order to do any of that, you're going to have an ability to show that you've impacted. And impacting comes down to metering. So on Wednesday, we're going to be diving into the different types of metering. We're going to talk more about what consumption and demand is. We're going to dive a little bit into utility bill structures and rate structures. I do not profess to be an expert on rate structures. We'll have someone on that topic in the near future, but we'll be going through that on Wednesday. And then Friday, I have already forgotten what Friday is going to be, but I know it's something cool. I just don't remember exactly what. So that being said, thank you so much, everyone, for being here. As always, podcast.smartbuildingsacademy.com/370. If you found this valuable, please like, subscribe, leave us a review, leave us a comment, share it with your friends. And if you're looking for training for your team, maybe you've got some last year or end of the year budget dollars left and you want to prepare your team for next year, definitely. Oh yeah, Andrew, you're right. Wireless is what's going on Friday. Thank you. If you've got some end of year budget dollars that you have to use or lose, and you want to get your team or yourself skilled up, definitely go check out our courses. There will be a link to that. I think we're at over 12,000 students now across 2,000 companies. It's pretty wild. We started 5 years ago, and we've seen some pretty great growth thanks to all of you. So I definitely appreciate that. And if you would like to see us talk about something else in the near future, let me know. It will be, I love talking about this stuff, and anything we can cover for you all, let us know. We'll either tap on our network to pull someone in, or I'll talk about it myself. So I hope this helped. There's a lot of talk. Okay, let's see what Christopher's saying here. There's a lot of talk about regarding metering technologies and types. Ultrasonic meters are becoming super useful for audits on hydronic. Yeah. So that is something that is interesting. Ultrasonic is very interesting because flow and temperature, right, are going to be our primary ways of calculating BTU loads. And BTU is what it's all about, right? Because BTU is going to indicate what kind of capacity needs as well as loading we have on our system. And hydronic is the place where simple efficiency increases can have large scale effects. Because if we think about it, right, a rooftop unit, maybe a rooftop unit is a 40-ton unit, but you may have, 400-ton chillers and a couple of them. And if they're a kilowatt a ton, I'm just throwing numbers out here. I'm not even trying to be accurate, but let's just say it's a kilowatt a ton, and you can reduce that by 20%. That can actually end up being a significant amount of kilowatt hours and kilowatts that you're reducing. So you can have and the thing is, any efficiency you do on the air side typically will have upstream effects to the hydronic side. So at the end of the day, our lowest hanging fruit is hydronics, followed by air side, followed by space, terminal units, etc. There you have it, folks. I hope this helped. I hope that gave you a baseline understanding. Unfortunately, I can't share a lot of this stuff on my screen because a lot of it is copyrighted. Oh, that's Siri. So a lot of it is copyrighted. So unfortunately, I can't share it on the screen because it's copyrighted, but I could talk through it and I can definitely link to a lot of this stuff. As always, we will have everything available in about an hour at podcast.smartbuildingsacademy.com/370. Once again, that's podcast.smartbuildingsacademy.com/370. If you like this topic and you want us to do more on this kind of stuff, please let me know. Like I said, we're going to have someone to talk about the, I think it's 179D, which is the $5 per square foot tax deduction. It may be tax deduction. It may be tax rebate. I think it's tax deduction, though, if I remember correctly. So that's going to be pretty major from a retrofit perspective. So definitely go and study that. All right, that's it. That's all I got. Not seeing any more questions. Thank you, everyone, for being here. I hope you all do well. I will see you all Wednesday. Definitely, if you got end of year funds, check out our training. It's a good way to get you and or your team prepared before the coming year. Thanks so much, everybody. Have a great rest of your day.